Hello everyone. Today we'll be discussing stacks, which we have already started previously in the earlier classes, in the previous session. Today actually I'm going to continue the discussion on stacks. Okay. Last class we did this. We had declared this declaration.h in which we created the stack. So let me elaborate what is this stack all about and why we created the data structure like of stack data structure like this in our program. So we are going to do the very first operation, which is stack creation. But before that we have to have the architecture of stack given in our program. The architecture of stack we have given in a program like this. We have created a structure. In this structure, we have created a user-defined data structure called stack. Okay, so which will represent stack. This is user-defined data structure for stack. In this user-defined data structure for stack, we have user-defined data structure for stack. Now in this data structure we have two things. One is this, which is pointer to array. This is going to be stack array in which the elements will be stored, and this int top, this is index into the stack array. It will always be on top index allocation of array always. Okay, I hope you understand this. Now we have started implementing some functions. We have implemented the main menu. Let's go to the main and the main menu function. Now look at the whole thing in this declaration.h header file. We are going to use array of function pointers. The total number of functions are going to be 2. This is your file called declarations.h. In this declarations.h header file, okay, this is going to be the total number of functions. Used in the program. Okay, this is the stack itself. stack data structure. Now this is the looking at this thing, we are going to use generic functions and array of function pointers. Okay, for this whole thing, this is array of function pointers, right? So let's have a look at these functions one by one. So let us have a look at the functions one by one, starting with the init function. In the init function, we are going to initialize all the function pointers that we have used till date. Let me give the sample code in your Jamboard also. This is your init function. This is init function implemented in init.h. Init function. Okay. This function is used to initialize and initialize all function pointers. Okay, so look at this here, storing the addresses of function in array of function pointers. Okay, right, this is init function. After that we move to main function. Okay, yeah, that's how the syntax goes, because what you have to store in the pointer is you have to store only the address of the function. The name of the function is the address of the function. If you will put parentheses also, that will mean that you are trying to make a function invocation. Now we come to main. In the main, we've declared the stack here, which is going to be our actual stack. Let's discuss this a little bit. We are right now discussing what we have already implemented in the previous session. This is main function. It needs some mention here. No, the main function works like this. We declare stack pointer. This is going to be a pointer which will be pointing to your stack. The original stack pointer. Why I call it original? I'll elaborate this in a moment. We invoke in line number 8. We invoke init function so that all function pointers are declared and initialized. Okay. Then we made stack as null, means right now we don't have stack in line number 9, making stack pointer null means stack doesn't exist. Not exist. After that we call main menu in an infinite while loop. Then the control goes in main menu. Let us have a look at main menu. The main menu displays the main menu, and it gives you various options 1 2 3 4 5 6 0. Okay, obviously you will be giving 1 first. So that is the first task you have to do, that is the create stack. So what we do is one create stack should be displayed only when the stack pointer is null and passed as an argument. So null is being passed as an argument, and null comes here in the ARG. The ARG which is null is copied into STK. Now in the main menu you will do like this: if not STK, that means the stack pointer is null. Then you will display create stack. Else, if STK is a valid pointer, then only you will display the rest of the stack, rest of the main menu. Okay, and these two things will anyway be displayed. Okay, end of the function. So now let us implement these functions one by one, and later on we'll fill in the logic in these functions. Okay. Yeah, we have passed stack from main as an argument. The stack is right now null, which is passed as an argument to the main menu function and is captured in main menu in ARG. I have copied ARG into STK stack, and that is what we are checking. If it is null, you print only one menu item, create stack. If it is not null, that means stack is already created. In that case, you will display a rest of the menu items. Okay. Mhm. Yes, so we will update it. We'll return it. Yeah, we'll accept that. Let's. I think it is at right place. So I think scanf is at right place. Please enter your choice, and then you get the choice. Manish, I have told you earlier also. It is difficult to talk to you because you are using speakers. I suggested you please use headphones. Otherwise, your voice comes to us and it echoes, and we are not able to listen anything. Okay, so let us implement the create stack function first. Okay. The name of the function is same as the name of the function should be name of the file should be same as that of name of the function. Okay. So create stack.c. Right now I will not do anything inside these functions. I will just give the function prototypes, that's all. Void star create stack, argument is void star arg, and I will keep it empty for now, and it will return arg itself. Okay, create stack. The main menu will also return the SDK. ARG rather. Okay, and the new create stack function will also return ARG. Another function that we have to create is push element, pop element. Push element.c, pop element.c. Then we have to create display stack, search into stack. Display stack, search stack. Then we have to implement destroy stack. Destroy stack. Okay. One by one we should set up these functions as well. This is push element. Then pop element. I'm just creating empty functions now, empty functions right now. Then you have display stack. Then you'll have search stack. Then you'll have destroy stack. Done. Done. All these functions are defined now. In the declarations.h, we have to declare these functions. So we have push element, pop element. Now we have create stack first. Create stack. We have push, pop, display stack, and destroy stack, search stack. create stack. Then we have display stack. Then we have search stack. Then we have destroy stack. In between we have push and pop. Push element, and we have pop element. Okay, then total number of functions is 1 2 3 4 5 6 7 8. So total number of function goes up to 8, and we have array of function pointers also. In the initialization function, we have to initialize, these are all extern, so these are, we need to declare it separately. In the initialization function, we'll declare it in the global space. Done. And then we have to initialize these. So we have create stack, then we have push element and pop element. Push element, pop element, then we have display stack, search stack, and destroy stack. So these are function pointer, and function pointer numbers 2, 3, 4, 5, 6, 7. So 2, 3, 4, 5, 6, 7 will be called from the main menu. Main menu create stack option is 1. So we have to call these functions now from the main menu. And the functions will be called using the array of function pointers, which is star ftr. Index will be ith function will be called. Okay, ith function is, suppose create stack you have given 1, but actually its index is create stack is 2. So it is 1 plus 1. I plus 1 will make it 2. Push we give 2. I will be 2. 2 plus 1 is 3. 3 is your push. So it's correct. So ith plus 1th function will be called, and the arg that was accepted as an argument will be passed further as an argument into whatever function you call. So this is all stack functions will be called one by one, and those functions you have already implemented here. All the functions are here. So let us save this program, okay, properly, and run. So what will happen is, here from main menu, oh, this will address later. So all the functions are now created and should be invoked. These are the functions. Let us go to the make file. We have not created make file. We have to create the make file also. So bin bash we have to create the stack program from main.o, from init.o, from main menu.o, from exit function.o, from create stack.o, from push element.o, and from pop element.o. Another function is create stack display stack.o. Then you have search stack.o. Then you have destroy stack.o. Then we have to compile and link these programs into a program called stack. All these dependencies will be resolved like this. Main.o will be created from main.c, headers.h, declarations.h, and the rule is gcc compile only, enable all warnings from main.c. Now init.o. Okay, then you have main menu. Then you have exit function. Then you'll have create stack. Create stack, destroy stack, display stack, search stack. Create, destroy, destroy, display, and then search. Okay. And then you have two more functions. These are push element and pop element. Okay, so this is done. Display stack. Oh, सब जगह गड़बड़ है. Search stack, destroy stack, okay. Make exit function तो बनाया नहीं हमने. So copy /training batch number 153. इसमें लिंक लिस्ट बनाया था ना हमने. इसमें एग्जिट फंक्शन बनाया था. इसे कॉपी कर लेते हैं. So that is the exit function that we had created earlier for linked list, and we copied, pulled it here. Make. Oh yeah, we need strncmp. That means we need a header file. The header file is a string.h. We need string.h. we have not included string.h. Make control reaches end of non-void function, exit function. Why so? Okay, we have accepted the argument as a void, and we are comparing it after comparing arg converted to char star compared with this exit success. Okay, exit 5. Yeah, we have to return arg as it is. Whatever is captured as argument will be returned back. And now test. Make no rule to make target push element needed by stack. Push element spelling mistake in the make file, I think. Push no. Check the file name. Push element is also okay. Push element appears to be fine. Where is the mistake then? Push element. It's okay everywhere. Here in the dependency, MENT. Here. Make. Everything compiled successfully and the stack is created. You call stack. That is. Only create stack option you have. 1. Enter. So create stack begin and create stack end functions were called. Then you're back to main menu, and then you have to display 0 for exit also. Segmentation fault. Okay, we'll check that. So create stack and exit option should also be displayed, isn't it? So let us take this out here. Now let's start working on it. Let's start working on create stack. Let's go to create stack first. In the create stack function, we have to allocate space for this stack structure. Okay. So it's very easy to do that. You create a pointer of type stack structure. You create a pointer of type stack, call it star stk. And then we will stk is equal to malloc space, how much space? Size of stack, and then typecast it to stack pointer. Check for errors if the memory is allocated successfully. If not stk, then it is an error. If it is an error, then you call the error and display the error message coming from malloc, and then call the exit function. The exit function prototype we have not given. You have given 0, 1, sorry. And then we have initialized in the initialization function the exit function as function number 1. So if in case of there is some error, then we have to call this function number 1 star fptr. Function number 1 will be called, and the argument that will be supplied here will be failure as string typecast it to void pointer, because you are supposed to pass only void pointer as arguments. This void pointer will go in exit function and will be captured here. Then you are comparing this void pointer arg, which has captured failure here. So it will capture failure and compare with failure 7 characters, and it will do exit failure if needed, right? And then out. Exit function is done. The create stack function is not full done, half done, because inside the stack there is a stack PTR also. So we have to set up space for stack PTR also separately. So, oh, we need one more thing inside this. I just realized we need size of stack also. And size, we need size also. What is the size of the stack? Who knows? So here we'll say enter stack size, and the entered stack size will be stored in entered from the user as an integer number, and will be stored in stk points to size. Means inside the stack structure there is a variable called size. In that variable here we will store the size. Okay. Then inside the structure, if you notice, there is a top also that you have to initialize. So you will make stk points to top is equal to -1 initially. Okay. And then there is a pointer to stack PTR. You have to allocate space for this, like this. So stk points to stk ptr stack pointer is equal to malloc size of integer, you have to store integer numbers, into size that you have entered. Stk points to size that you entered from the user. Suppose you entered 10, so you have allocated space for 10 integers and typecasted it to integer pointer and check for errors. Okay. If in case there are some errors, then you will go out, but before going out you will free memory allocated to stk here. Okay. So now you will have your memory allocated for stack like this. You will have memory allocated for your stack like this. This stack pointer which was initially null will now be a pointer. In line number 6 there is stack pointer. You would have allocated space for stack structure, in which you have stack size, you have top, and you have stack PTR pointer. Size you have made say 10, top you have made -1, and this PTR points to actual stack array. This is your stack array, and the starting address of the stack has been stored in this. So the stack is created like this. Okay. Yeah. And then first we had to allocate space for the structure. we have to allocate space for the structure. When we allocate space for the structure, we allocate space for 4 bytes for integer size, 4 bytes for integer pointer stack ptr, and 4 bytes for int top. So the size of the structure is 12 bytes here. The 12 byte structure is created. Now these 4 bytes that are allocated for the pointer, this pointer needs to have an address. Okay, it is a dangling pointer right now. So what we did is, for this particular pointer, we created a stack array. Stack is being implemented in an array. Okay, so where is that array? So this array is allocated now, and the starting address of this array is stored in stkptr. Yes. We did malloc twice. First we did malloc for this 12 byte structure, and then no. If I would have declared this as a structure variable, if I would have declared this as a structure variable, then memory would have been allocated. But we did not declare structure variable. We have declared structure pointer, and this pointer needs to be allocated with memory, and this pointer needs to be initialized. So we allocated space for the structure. Okay, typecasted it to structure, and now this is a structure pointer. This structure pointer is pointing to structure, in which there is size, there is a top, there is a uninitialized dangling pointer. Then after that, I have allocated space for array, and the starting address of array is stored here. Now this becomes pointer to array. Now this array is your actual stack. Yes, you have to malloc separately for the stack array, and before that you have to do malloc for the stack structure also. Yeah. Fine. So this is how the structures are created. So I hope it is created successfully. Now the STK that we are returning, the data type of STK is stack pointer, but we had promised that we will return void pointer. So we must typecast it to void pointer before we return it. Void pointer, and the returned void pointer from create stack is now will come back here and will be captured in, say, arg, which is a void pointer which was supplied to main, which was null, will now become not null, isn't it? And will be returned back. When it will be returned back from main menu back to main, and in the main you will capture it in the original stack pointer, which was null. Now it will become not null. When it will become not null, it will be again passed as argument not null this time. So when it will come here not null this time, it will be assigned to stk not null this time, and you will check if it is not null this time, it will display the rest of the menu items. Sorry? Are you talking about this? We have returned the void pointer, and the void pointer has to be typecasted into stack pointer. That's correct. Stack pointer. Nice. Okay. Good. So let us run this program and see if it works properly, or if there will be some bugs, we'll resolve it. So let's go to makefile and add a label here called clean label. Well, we'll ignore warnings, remove all object files, ignore warnings, remove the previous executable stack file. Now you do make clean, remove the clutter, and then make again, and then run stack. Now exit program is being displayed. 1 for create stack. Enter stack size 10. Okay. Yes, enter stack time, stacks over, and now see 2 3 4 5 6 0. Now rest of the menu items are being displayed. 2 3 4 5 6 7, isn't it? So I do 0 for exit right now. So it exited. Oh, it did not exit. Exit function begin, exit function end. It did not exit. So we have to see what is the problem with main menu. Go to the main menu. Here it is, main menu 2 3 4 4 0. When it gives you 0, yeah, that's right. If your I, that is choice, that is entered, is equal to 1, then you're going to call create the stack function. You call create stack function. Else, if the entered value is 0, I is equal to 0, then you are calling the exit program. So this function pointer will be used like this. Now when we are calling this function, we are not calling all stack functions. Here we are calling only create stack function, and here we are calling only exit function. When you are calling exit function only, you won't pass arg as argument. You will pass exit or failure. This is success. You are exiting with success, which is a string pointer typecasted to void pointer. Okay, and you will not be collecting any exit code return value from here. Okay. Else, if the value of I is between greater than equal to 2 and value of I is less than equal to 6, then this is a valid index. No, less than equal to 5. No, it's 6. Then it's a valid index, and then you will call the rest of the functions with arg as argument. This is all stack functions, and remember, you will not capture any exit code from here. Okay, this is how we did linked list also. Now it's fine. Let's see if we are able to do exit now. Make clean, make run. 1 for create stack, size is 10, and then 0 for exit. Yes, we are able to exit properly now. Okay, create stack is also working fine. So nice development we have done, and rest of the things that we are left with, the actual operations, push, pop, and then display, destroy, search. This we had yet to implement. So I'm out of time. Please watch for the next session where we'll implement these operations also. Okay, thank you.